Hello and welcome to Physics Fix, the show that will cover the entire range of physics, expose you to new theories and brush up your existing fundamentals in the subject to help you score high in your exams. The mantra of our show is simple: Funda right, to career bright. I am Siddharth Pinto, and together we shall explore this world of physics. Physics is all around us, right from the spring balance used by our Raddiwala to the beam balance used by our neighborhood jeweler who measures every single gram of gold for you. We shall revisit all such laws, theories, and many interesting experiments on this show called Physics Fix. So, which aspect of physics are we studying today? Let's take a quick look at the highlights of today's show. Today in Physics Fix, we shall fix your fundas on electromagnetism and revisit Oersted experiment. Take a look at fundas related to strength and the direction of a magnetic field due to a current-carrying conductor, and understand electromagnetic fields using Biot-Savart's law. And of course, we'll top it all up with an exclusive sneak peek into your final exams question paper. Right, so let's get straight to it. Today's topic is electromagnetism, but before we start, let's introduce you to our magnetic professor, Sanjeev Sarma. A magician of sorts, he makes every formula of physics seem like a nursery rhyme and every scientific gadget look like a toy. With a master in particle physics from Mumbai University, Sanjeev Sarma has been making instructional packages for students for many years. With proven 100% success rates for his students, Sanjeev will share with you some radical new ways and methods to crack your exams. Presenting the star of Physics Fix, Sanjeev Sarma. Professor, welcome to Physics Fix. Pleasure to have you on the show.
Thank you, sir.
Before we fix the fundamentals of students, let's listen to some of the ideas and thoughts of students so that we can shape our tutorial better. Here are some of their views on electromagnetism.
Sometimes become difficult to understand electromagnetism since the basic concepts are very complex.
Not a subject to score because mostly students don't pay attention to it, take it as very tough.
If you know the basic concepts, then you can go on with it very well.
3/4 of the students say that electromagnetism is very difficult.
So if we change the magnetic field, there is a flux, and also if there is a change in the magnetic flux, so there is EMF introduced in that.
Faraday was the founder of electromagnetism.
Right, so many questions, so many points of view on electromagnetism, Professor, but was there a lot of truth in all they said?
Yes, there was a lot of truth, and yes, there's a lot of misconceptions too. Electromagnetism is a pretty easy subject to understand, but only when you see it as a concept, when you see images in your mind, when you see visuals, is when electromagnetism really starts becoming a beautiful subject for you to study. And once that happens, believe me, you're the king. Electromagnetism, my friend, is powering the world around us. Everything that we see around us, in our cupboards, in our pockets, everywhere is electromagnetism. And hey, let's take a look back into the early 1800s when Hans Oersted ran an experiment to check out the thermal properties of electricity, which led to discovering the science of electromagnetism. Let's look at it in this special section that we've created just for you called Lab Vision.
So this is Oersted's experiment performed for the first time in the 19th century. The tools, as you can see, which Oersted used: a battery, a magnetic compass, a copper wire, a resistance in a form of a bulb in our experiment, and a switch to control the electric current in this circuit. When current is passed, as you can see, a deflection is noticed in the magnetic compass. As the compass is placed below the wire, the needle moves in the opposite direction. And lastly, when the flow of current is from east to west, there is no deflection noticed in our compass at all.
Siddharth, wasn't that beautiful?
Absolutely, and you can make out that it was completely by accident that he discovered this, wasn't it?
The entire experiment happened by mistake, and what's more, Oersted did not know what was happening. It was André-Marie Ampère of France who discovered that around a wire carrying current, there is a magnetic field generated. And hey, we now have two types of forces associated with electricity. The one is electric, the other is magnetic. Let's see where these two fuse together in our next Lab Vision as we create an electromagnet for you.
Always wanted to know how to make an electromagnet yourself? Well, here is how. Take this iron rod and hold it near the nails. Initially, it won't attract any nails since it has no magnetic properties as yet. However, when you coil this copper wire around the iron rod and connect its end to a battery, a current starts to flow through the coil. And now when you drop iron pins on the same iron rod, the pins cling onto the rod, proving that the iron rod has gained magnetic properties. Magic? No, just simple electromagnetism.
Electricity relies on negative and positive ions to define its direction. Magnet relies on north and south. But how does one check the direction of a magnetic field around a conductor carrying current? The answer is defined by Maxwell's right-hand thumb rule. The thumb indicates the direction of the flow of electricity, and watch my hand as I move it. The direction of movement inwards towards the palm explains the direction of the flow of the magnetic field, and this indicates the direction of the flow of current. Wasn't that simple? Let's get into our lab vision and take a quick look at magnetic fields around a circular loop that are carrying current.
Let's take a quick look at what happens when an electric current passes in a circular loop. As you can see, it creates a magnetic field at every point in that same circular loop. This magnetic field is more concentrated at the center of the loop rather than outside the loop.
We've seen what happens to a magnetic field around a single loop that carries current. But what happens when hundreds such loops of wires are stacked together? The intensity of magnetic field at the center of this stack becomes intensely huge. Stacking such loops together gives you something called as a solenoid. The magnetic field inside a solenoid is explained using the following equation. B is equal to mu 0 Ni, where mu 0 is the coefficient of permeability, B is the intensity or the strength of the magnetic field, N is the number of turns that are present in the solenoid, I is the amount of electric current that is flowing through the conductor. Let's take a look at the force fields around a bar magnet and a solenoid together. Back to lab vision.
In this visual, we look at the similarity between the force fields of a solenoid as well as a bar magnet. You can see how the field lines flow from north to south, both in the bar magnet as well as the solenoid. More than enough evidence to show us that a solenoid, which is nothing more than a magnet created by electricity flowing through a coil, is very similar to a bar magnet.